Arithmetic sequence. So arithmetic sequence is one that there's a constant difference between the succeeding terms. So if my terms are u1, u2, u3, un, correct? Then your difference is the same. Difference between the second term and the first term, correct? The difference between the third term and the second term remains the same, correct? Which is the same as the difference with third term and second term. That remains the same. The general term formula un is given by u1 plus n minus 1 into d, where d is the common difference, u1 is the first term. The sum of n terms is given by the formula n over 2 u1 plus 2u1 plus n minus 1 into d. The sum of n terms. The sum of n terms is also given by the formula n over 2 u1 plus un. Okay. Now also you need to remember that your general term is Sn minus 1. Very, very important. This is an important formula. So if I give you the Sn ka formulas, your general term you can find out by Sn minus 1. Don't forget that. So huh? Sorry. If I give you sum of n term formula to find the general term, so un is equal to Sn minus 1. Okay. Now geometric sequence. What's the geometric sequence? So your there's a common ratio. So your common ratio is r is equal to second term upon first term, which is same as the third term upon second term. Basically, which is same as un upon un minus 1 term. That ratio will remain the same basically. The ratio of the succeeding term of the preceding term will remain the same. You want r raised to n minus. This is then your formula booklet. Yeah, correct. Then Sn sum of n terms is equal to, yeah. So if r is greater than 1, you apply this formula. If your r is less than 1, if your r is less than 1, you apply this formula. Which one? It's for, it won't, see, it won't matter. On a bigger scheme of work, it won't matter. On a bigger, larger scheme of work, it won't matter. Yeah, that is if your sum of infinite terms, is 1 minus r. This is the condition for this is your r should lie between minus 1 and 1. Remember, this is the condition that should apply for the sum of infinite terms to exist. So therefore I must have written that over here. So in a bigger scheme of work, it won't matter. So yeah, so yeah. So then this you have to use it this or when I r is less than minus 1 basically. For the bigger scheme of work, it won't matter. Put the sigma notation. Sigma notation can be used for arithmetic or geometric. Sigma basically is the sum of all the terms. So if I have u1 plus u2 plus u3 up to un, so if you want a sum of all these terms, we can simply put it sigma, correct? R is equal to 1 to n and you put the general term over here. So here you have to put the general term. You put the general term. Here this is your start. You start with R is equal to 1 and you end at this point. Correct? So sigma. Sigma is sum. So general term is your ur is your general term, and your r is your variable which takes values from 1 to n. So when you first you take your r as 1, so you'll get your u1 plus, then you take your r as 2, you'll get u2 plus, then you take your r as 3, you'll get u3 and so on and up to un. Okay, so now arithmetic sequence has the first term ln a. So u1 is ln a, correct? The common difference is ln 3. The 13th term is 8 ln 9. So basically your n will be 13 because it's the 13th term. Find the value of a. So apply the formula un is equal to u1 plus n minus 1 into d. So your 13 is equal to u1. My u1 is ln a plus n is 13 minus 1 into d is equal to ln 3. So u13 term is going to be 8 ln 9 ln a plus 12 ln 3. Right? So 8 ln 9 minus 12 ln 3 is equal to ln a. We are solving for a, no? So now, so ln 9 raised to 8 minus ln 3 raised to 12 is equal to ln a. So ln a is equal to ln 9 raised to 8 upon 3 raised to 12, no? Because you are applying the ln formula. See, ln m minus ln n is equal to ln m upon n. Now you drop the ln on both the sides. So 9 is nothing but 3 square, correct? 8, 3 raised to 12. So 3, 8 2s are 16 minus 12. So 3 raised to 4. So how much is 3 raised to 4? 81. Okay, so let me just do it for completion of this. So your common difference, what will the common difference be? u3 minus u2, correct? The third term minus the second term. Okay, so your common difference is the third term minus the second term. It's 11 minus 5, that is 6. Then the first term, if you're finding, your second term is basically first term plus the difference, correct? So your second term is 5, your first term in a difference of 6, so this is minus 1. Sum of n terms, so Sn is equal to sum of first 20 terms, so n over 2 2u1 plus n minus 1 into d. So n is 20, first 20 term n is 20, so 20 over 2 2u1, 2 into first term we got as minus 1 plus 19, correct? 20 minus 1 is 19 into d 6. So this is 10, this 10 minus 2, 114, correct? Yes? 1120. So what you need to do is, how do you find the common ratio? So the first three terms of a geometric sequence are given. This is my first term, this is my second term, this is my third term. For x is greater than 0, find the common ratio. The common ratio, you can take the second term upon first term. My second term is ln x raised to 8. First term is ln x raised to 16. So that is equal to 8 ln x. So that is equal to 8 ln x, correct, upon 16 ln x. So ln x ln cancels. So half. Part B. Solve. Now see, sigma is given, k is equal to 1 to infinity of 2 5 minus k ln x is equal to 64. You have to solve. Solve means you have to find the value of x basically. So first you expand it. So this is your start value. This is your end value. So they are sum of infinite. This is meaning of sum. Sigma means sum. This is the sum of infinite terms. And this is my general term. So first you take your k is equal to 1, put it here. So 2, 5 minus 1, correct? ln x plus 2, 5 minus 2, because are you following up to 2? You keep on changing the values of k. You keep the changing of values of k. 5 minus 2, ln x plus 2, 5 minus 3, ln x, and so on. You keep on going, and the sum of infinite terms is equal to 64. So now what's going to happen is, so what will this become? What is the formula of sum of infinite terms? So this is your 2 raised to 4 ln x, correct? Plus 2 raised to 3 ln x, plus 2 raised to 2 ln x, and so on is 64. Now if you see, this is the same sequence which was given earlier, because this is 16 ln x, correct? Because the first term here was, so this is basically 16 ln x. If you get the power in front, you know that rule, no? Log m raised is equal to m log n, in the power in front. So basically this is the same sequence that we have, and we have sum of infinite terms. Now what is the formula of sum of infinite terms? u1 upon 1 minus r. What's my u1? My first term? 16 ln x. And 1 minus half. So now what is your 1 minus half? Half. So 16 ln x is equal to 64 divided by half. So that's 32 ln x is equal to 64. So ln x is equal to 2. So x is equal to e raised to 2. Yeah? You're converting your log form to index form. You know that now you have to push this up. So x is equal to e square basically. So you know these are the sum. This is the sum of the terms. So don't confuse that. This is the sum of the terms. Follow the sequence. This is S1. S1 means sum of one term. S2 is sum of two terms. S3 is sum of three terms. S4 is sum of four terms. The sum of the terms follow the sequence. Given that U1, the first term is given, find U2. So what will U2 be? Now I've given you that formula if you remember. Your UN is equal to, this is an important formula. This is not there in your formula booklet, so you must learn this out. So that means if you follow this formula correctly, so so U2 will be S2 minus S1. S2 minus S1. So minus S1 is 1 plus K. So that will be 4 plus 2K, correct? U3, you have to find out U1, U3. U3 will be S3 minus S2. So sum of three terms, that is this minus this. 12 plus 7K minus S2 is 5 plus 3K. So when you open the brackets, it's 7 plus 4K. Correct? U4. Wait. U4. What is U4? What did you get your U4 as? U4 12 plus 7K. So 10 plus 8K, na? 9? They haven't mentioned an arithmetic or geometric sequence. They have given you the sum of the two. No. You can't do that. You can't do that. You keep on applying this formula over and over again. The sum of two terms minus sum of one term. Why? You can't assume no arithmetic. It can be anything. The U3, this is irrespective whether it's arithmetic or geometric. The irrespective of any sequence, yeah. So U4 is S4 minus S3. So this minus this will give you the fourth term. This minus this will give you the third term. Apply the formula straight. So what will I do is, so I'll line this, I have to find a general term. So I'll see the pattern which is there in part B. Find a general term for UN. What's my U1? 1 plus K. What's my U2? 4 plus 2K. U3 is 7 plus 4K. Correct? U4 is 10 plus 8K. Now, this is my u1, u2, u3, u4. Now, is this arithmetic or is it geometric? See, if it's arithmetic, the common difference would be the same. Now, clearly the common difference is not the same. Check, na? So, if you do this minus this, so this is not arithmetic. Is it geometric? Is the ratio of this upon this same as the ratio of this upon this? No. So now what you do is you split this into two parts. Suppose if you take 1, 4, 7, 10, this will be arithmetic and this will be geometric. So what's going to happen is, so you take the first part 1, 4, 7, 10. If you look at the difference, this is 3, this is 3, correct? 7 plus 3. So this is 3 basically. Yeah. So then I can get my un is equal to u1 plus n minus 1 into common difference is 3. So 1 plus 3n minus 3. That is 3n minus 2. That's the first sequence, this part. The first part, 1, 4, 7, 10, this is my arithmetic. Now the second part which is there, that's your k, 2k, 4k, 8k. Now 2k upon k is what? 2. 4k upon 2k is what? 2. 8k upon 4k is 2. So it's a common ratio. So the second part is forming a common ratio. So my general term un is equal to u1 r raised to n minus 1. So u1 is my first term, which is k. Here this is my first term. K, r is your common ratio, which is 2 always, raised to n minus 1. So therefore, for the sum, my general term will be my general term un overall. Correct? This is my arithmetic sum un, and this is my geometric un. This is the arithmetic un plus the geometric un. So 3n minus 2 plus k 2 raised to n minus 1. This is my answer. So what you need to realize is that the first part forms an arithmetic sequence, the second part forms a geometric sequence, and my general term is the sum of the arithmetic sequence and the geometric sequence plus general term. Very, very important sum piece. So very important sum. So SNs are given and you're getting UN. So R is equal to second term upon first term. So again, this is a very easy sum. So R is equal to second term upon first term. My second term is 16 over 32. So R is half. Then find U6. It's a geometric sequence. U1 R raised to 5. N minus 1. So 6 minus 1 is 5. So U1 is 32 half raised to 5. So how much is that? 32 into 1 over 32. Correct? 1. Sum of infinite terms. U1 upon 1 minus R. My U1 is my first term. 32 upon 1 minus half. So 32 divided by half. So that's 32 into 2, 64. Correct? Common ratio. How do you find a common ratio? The common ratio is second term upon first term. So second term is 1/4 a square minus 3a and your first term is a. Correct? So if you remove a common, what will be left with? 1/4 a minus 3 upon a. A is greater than 0, so you can cancel. A is not equal to 0. So basically my common ratio is 1/4 a minus 3 or a upon 4 minus 3. Find the values of a for which the sum to infinity exists. Now sum to infinity exists. Sum to infinity exists when your r lies between minus 1 and 1. So that means minus 1 is less than 1/4 a, minus 3 is less than 1. You know how to solve this, no? You can solve this part and you can solve this part. 1/4 a minus 3 is less than 1. You solve each part separately. So 3 minus 1 is equal to 1/4 a is less than 9, correct? So 4 to the, you multiply that 4, A, correct? The 1/4 A is less than 4. So that means your A, when your A lies between, well, let me just do this much one. Correct? So the part B ka answer is what? When your A lies between 8 and 16, the sum to infinity exists. Find the value of A when sum of infinity, so sum of infinite terms is equal to 76. So u1 upon 1 minus r is equal to 76. So u1 is your first term. What's my first term? A upon 1 minus r. Your r is 1/4 A minus 3, correct? Yeah. Now you can put in your solvent. You know how to put solvent? So you can also do it by hand if you want to. So A is equal to, if you don't like using solvent, you detest using a calculator, then you can just cross multiply. So A upon 4 plus 3, correct? So A is equal to 76. If you take the LCM, okay, first of all you do it 4 minus A upon 4. So then this will be 76. 4 4s are 16 minus A upon 4, correct? Then this is 4 1s are 4 9s are 36, correct? So A is equal to 19 into 16 minus 19A. So 20A is equal to 19 into 16. Yeah, so you can put in solvent also, yeah, but this is also fine. So 19, yes, no, yeah, no problem. Divide by 20, yeah. But some people can't do it, no? So 15.2, yeah. So 15.2, which makes sense since it lies between 8 and 16. Now this is also a direct sum. The first term is given, the second term is given. You have to find out R, but obviously use a calculator please for this. Yeah, find the value of U10. Again use a calculator. Find the least value of n for which your Sn is greater than 5543. Okay, so calculator, paper 2. So what will you do in this case? So R, so R is equal to second term upon first term, correct? 2.226 divided by 2.1. So, please use your calculator when such things are there in exams, so that you save time for the tougher sums in the end. Are you following that? So don't, yeah, because you'll need time to save time. So 1.06. Okay, B, U10 is equal to U1 into R raised to 9, correct? UN R minus 1. It's a geometric sequence, no? Now be careful, read this well and underline it in exams. Don't use the wrong formula. There's a lot of children apply the wrong formula. 1.06 raised to 9. So 2.1 into 1.06 raised to 9. Correct? So 3.55. 3 significant. Correct? 3 significant figures, that's the answer. You can write more significant figures and then you can write 3 SL. The least value of n for which your Sn is greater than 5543. So you apply your formula for Sn, u1. The formula is then your formula method u1 r raised to n minus 1 upon r minus 1. So that's your formula. So Sn is u1 r raised to n minus 1 upon r minus 1. Correct? Is greater than 5543. Now please don't waste your time in exam. You simply go to solvent r minus 1. calc solve n, correct, you make it equal to 2.1, open bracket, this is 1.06 raised to n raised to x, go right, minus 1 close brackets, divided by 1.06, it's 1.06 minus 1 is 0.06, correct, I am putting that, is equal to, you won't be able to put in greater than over here, is equal to 5543, 5543, correct, close brackets, execute, it will ask you more solutions exist, you exit, so 87.03. So when your n is 8, so when your n is 87.03, correct, you will make it equal. So you want to exceed it. So what is the smallest least value of n? Yeah, least value of n would be 88. Because when it's n is the number of terms, n has to be integer. It's not an assumption, it's a fact. Very good. Very good. That's the most important step. The second term is given to you as 7.98. And the sum of the infinite terms is given to you as 33.25. Now sum of infinite terms u1 upon 1 minus r is 33.25. Now you should know that your r is equal to u2 upon u1. Correct? So if you cross, so u1r is equal to u2. Therefore u1 will be u2 upon r. So you've been given u2, so 7.98 upon r. So you get 7.98 upon r divided by 1 minus r is equal to 33.25. Now, you know, rather than you can cross multiply and all get a quadratic and do it, but you can also use solvent. I mean, it's fine if you use solvent. So options, calc. Yeah, but here also directly you can use your solvent because but sooner or later if you are using a calculator, now this r you can get it down. So that's your x, open brackets 1 minus x, correct? Now if you do this, it's sorry 1 minus x. 1 minus x, yeah, because this will get, this divide by this will go like that, no, simple basic math is equal to 33.25. So solvent is very powerful basically, so it will save your time, you know. So 2/5 and 3/5, correct, possible values of r, so both are possible because both of them should lie between, remember that for sum of infinite terms your r should lie between -1 and +1. So both are possible. So sometimes you have to check that also. If it one lies out, you must graph this on your calculator. Now, whenever you're doing such sums, pi by 2 means this is in radians, and x is greater than 0. So you graph it in your calculator. So you do e raised to 2 sine, correct, open brackets, fraction pi x upon 2, correct, close brackets. You graph it, correct, and the kth maximum, so we're looking at the maximum point, so you're looking at the kth maximum point on the graph as x coordinate xk. So let's look at the maximum, so you have to read well. So g solve max, correct, so your x is greater than 0 means you have to take all the values greater than 0. So my first x1 is 1, my x2 is 5, you can see over here, okay, my x, this is 9, so x1 on your calculator you'll see x1 is 1, x2 is 5, x3 is 9, you're finding the maximums, correct. So that means that this is your common difference, no, basically. So your a is equal to xk plus 1 minus xk. So a is equal to basically you have 5 minus 1, it's a common difference. In simple words, rather than asking common difference, they are finding this. They find A. So A is equal to 4. Now part B. You got part B? Yeah. So again, let me repeat sigma notation. This is the start value. This is the end value. And sigma means summation, sum. So when you put your x as 1, then 2, then 3, correct? And the last value is xn is equal to 861. Basically the sum of n terms. Correct? Huh? This is basically sum of n terms. So sum of n terms basically is equal to n over 2, 2u1. 2u1 is x1, basically that's 1. Yeah, this is my 2u1. Correct? Plus n minus 1 into d. What's your d? D is a common difference, which is 4. Why are you doing all this? No, but why are you sitting with a calculator? Array, but if you're sitting with a calculator, there's no need to do anything of this sort. Then you just do this. Then so why should you do? Because what will happen? There are two things. You'll waste time, and if you get wrong unnecessarily, you're losing marks. So there's no gain. Okay, there's no gain out of the entire process. Okay, so what do you do in these cases? You do solvent, straight solvent, option calc solvent, correct? You have x 4x minus 2 close brackets upon 2 is equal to 861. Are you following that? You can do all that. If you don't make a mistake, it's good. But here directly you're getting it, you're sitting here using a calculator. So n is equal to minus 41 by 2 or n is equal to 21. So obviously minus 41 or 2 reject. So n is 21. And you go to the next sum straight. So in the geometric sequence, the fourth term is 8 times the first term. Now again, the sum of the first 10 terms is given to be 2557.5. Find the 10th term of this sequence. So I use my U4 formula. U4 is equal to U1 R raised to n minus 1. So U4 is 8, U1 is equal to U1 R raised to 3. Correct? So R cube is equal to 8. So R is equal to 2. 2 cube is 8. Correct? Now you've been given the sum of 10 terms. So apply Sn for S10 is equal to U1 R raised to n minus 1 upon R minus 1. So this is 2557.5 is U1. Now U1 is what? What's my first term? So you can find it out. So U1, correct? R 2 raised to 10 minus 1, correct? Yeah, directly right. So then you can basically this is 2557.5 divided by 2 raised to 10 minus 1, correct? Is U1. So 2557.5 divided by 2 raised to 10 minus 1. So it's very important you put a bracket here. So 2.5. So my first term is 2.5. Correct? Now 10 term. So don't forget it's geometric, underline it. In exams, children make a mistake here. So my 10 term is equal to U1 R raised to n minus 1. R raised to n minus 1. So U1